All right, we're taking a quick look at, in the 5 steps to 5 for the AP Chemistry group, question 13 from chapter 6 on page 84. It states, the solution is prepared for qualitative analysis. The solution contains the following ions. We have cobalt 2+, we have the lead 2+, and aluminum 3+. Which of the following will cause no observable reaction? So in combination with NH3, K2CrO4, HNO3, and K2S. Okay, so those are our options. And we're looking for no observable reactions. So let's see what potential reactions we may have with these ions. These ions are metal ions, and they're not group 1, group 2, of the periodic table. With our lithium sodiums, beryllium magnesiums. They're transition metals, or further than that, with aluminum being in this column over here. So they're not really known for their reactivity. They don't form soluble hydroxides. They're not going to form strong bases, like we see with the other metals. They're also low on the metal reactivity, so they won't tend to do single replacement reaction kind of things, just looking at, their identities. Lead is particularly insoluble. It's a exception to many of the reactions. So, but let's take a look at what potentially may happen with these. So with NH3, NH3 is actually a base, okay? It's the non-traditional base because of the way it interacts with water. So let's look at how that works here real quick. So if you have NH3 and HOH, let's call it, the NH3 will actually remove one of the H's from water, and you'll end up with NH4 plus and OH negative. So you end up with a hydroxide that's being produced. So it itself isn't a base. It just makes the solution basic, thus being a base, right? Like it's acting like a base because it's having these hydroxides develop, okay? So what does that mean? Well, with all of these, they will make because they're not strong bases, they can't make strong bases. So the cobalt will make cobalt hydroxide, which is a solid. That's a reaction. The lead will make lead hydroxide, which is a solid. Again, you see that as a reaction. And the aluminum would do the same thing. Only the strong metals from column 1 and 2 make strong bases that dissolve in water and actually get to act like a base because they split apart and have the hydroxides there. These are all going to form precipitates. In particular, the lead is going to be very much a precipitate. Okay, so you can get rid of A then because those would form a reaction by making precipitates. So what can we say about the K2CrO4 then? In that case, we will also have the chromate being in there. Chromates are very similar to hydroxides in that you will form precipitates with those as well, multiple ions, okay? Same kind of situation where the potassium snuck it in there because potassium is one of our reactive metals in the first column of the periodic table. So it comes in as an aqueous, and then the chromate will go through a double replacement, and this, and this will bond with it, but make a solid instead of it being aqueous. So we're going to see, again, solids formed here. And here as well, you can see that we're sneaking in the sulfide in D with potassium, same scenario, where sulfide and chromates should be a solid except if they're with an exception, which in this case is potassium in these cases. Could be lithium, could be sodium as well, but we're definitely seeing, you know, the same solids formed here. So this is a solubility type of question, and these all are behaving that way. So the one that we're left with is the nitric acid. So why is nitric acid different? Nitric acid is a strong acid, right? So in terms of the reaction with the 3 ions that we have indicated here, you're going to see a reaction where the cobalt kicks out the hydrogen, the lead kicks out the hydrogen, and the aluminum kicks out the hydrogen. So then they're going to take the place of the hydrogen, you know, in which case we're going to have these trying to combine with the nitrates. So what does that look like? Well, nitrate is extremely soluble. With no exceptions, okay? So again, this problem is basically a review of the solubility rules, but what they're saying is that this acts like a base and you get insoluble products. This is insoluble with non-exception metals, which these are, you know, non-reactive metals in the grand scheme of things, along with this one, behaves the same way. Snuck it in with the potassium. Then we look at this. This has no exceptions. Nitrate makes everything soluble. You can bring anything in with a nitrate and it's going to be soluble. And it can combine with anything and make it soluble. That's how we sneak in some of these heavy metal kinds of deals. It's like the opposite of potassium and lithium, and those guys sneaking in typically insoluble negative anions, right? In this case, we're using a trump card, ace in the hole here with our soluble nitrate to keep these soluble, okay? So that's why acid's such a good cleaner, because it can clean up things that other things can't touch. It makes things that are, you know, usually insoluble, soluble, and they can break them up. And so yeah, C is the only option that would make sense in terms of a non-observable reaction. You're going to mix it in there. There are going to be ions before. There are going to be ions after. Okay, so let me just write down a quick reaction. So let's say they don't say what these solutions are. Let's say they were chloride solutions. So we have cobalt, chloride. Okay, I'm just making that up just so you can kind of see what's happening in terms of a reaction. It's a double replacement. So the cobalt goes there. So you end up with cobalt nitrate. Need 2 of those. Then you would look at, well, we got the other part, but I made up the chlorine, so it really doesn't matter. This is aqueous, because chlorides are, you know, they're soluble too. And then this is aqueous. As a strong acid, it has to be. And after the reaction, that's when we have to ask ourselves, is this aqueous or not? And this, of course, is aqueous. This is a no reaction, okay? Like, I know I wrote it out as one, but because it's aqueous before and after all parts, if you did a net ionic, where you broke everything up and canceled out the spectators, everything would cancel. Everything would cancel out. So, and that's because of the solubility of this nitrate. The cobalt would like to form a precipitate, but it really can't because it's bonding now with the nitrate, which makes everything soluble. So the reaction is pretty much done at that point. So that's why it would make the most sense for 13 to be C. So again, one of the key points is looking at what you're you know, given for information, and but you know, being familiar with reactions particularly precipitation reactions with forming solid precipitates. And that's a good way to identify the correct answer in that